So good morning, and thank you for all showing up nice and early here this morning. I know it's chilly outside, chilly inside, so it's good to have you all here. So I'm Greg Maxwell. I'm CTO of Blockstream, and I'm also a developer of the Bitcoin reference software. I've been doing that for about 6 years now. And I have a background in distributed systems, cryptography. I spent a number of years working for Juniper Networks and for Mozilla, working on a variety of things, including multimedia codecs. And throughout my career, I've had a focus on figuring out where really interesting mathematical and engineering problems can make a transformative change in society at large. And so when Bitcoin came up, I'd been interested in digital currency for a long time. It was the obvious place for my attentions. So that's sort of how I come to all of this stuff. So I wanted to talk at a high level today about some of the challenges and opportunities that come when we take the technology that comes out of Bitcoin and apply it to the rest of the world, apply it to enterprise applications, apply it elsewhere. And there's so much promise and so much excitement around this that I think that there's a useful mental framework for decomposing the problems and thinking about it that I want to talk about today. So I think that one of the biggest challenges in thinking about the applications of Bitcoin and blockchain technology to other areas is sorting through the hype. And I don't mean this negatively or to say that it's overhyped, right? I think the technology has such incredible promise, so many potentials, that it is virtually impossible to overhype it, but that doesn't mean that there isn't a lot of hype. And this is a challenge because when we think about how we invest our time in development, where we think about how we, what products we shop for, what we deploy, what we trust, what we use, we have to sort through the hype. We have to understand what's a meaningful use, what's transformative, right? What changes the world, and what's kind of boring, right? And so, as I said, I'd like to talk a little today about some ideas that I think can help us do that. So I think one of the first ideas behind that is really important is that what Bitcoin means, what blockchain means, is different to different people. And that also means that what is hype is different to different people. And these different applications are legitimately valuable across the board, right? So if you're thinking about Bitcoin providing a new kind of money, then other applications of the technology may look like a lot of hype. And to you, they are hype, right? They're not going to change how you live. And I think as many different companies, as many different people talk about the technology, you can find that many different applications for it, right? So I listed some things here. Obviously, Bitcoin gives us a kind of money. There are many people and organizations that look to this technology as just an opportunity to operate under a different regulatory regime, right? And that's completely valid, right? They don't care about cryptocurrency so much. They don't care about ledgers and immutability. Just the existing regulatory environment for what they're doing has been captured by some old interest and is poorly optimized, and now that's an opportunity to do something fresh. And that's legit, right? It's an opportunity to refresh technologies, right? Like the specific advantages of this stuff, maybe they don't matter to someone, but just doing something new matters. It's certainly something that people are looking to hire for, right? So for developers in particular, it's an interesting area to be involved with. Looks good on a resume. People see it as a way to improve security. And we also look to a way to fix some of the systemic risks on the internet today by decentralizing and minimizing trust. And I'll talk a little bit more about that later. So I wanted to give a succinct definition of what is Bitcoin. And I think this is pretty important to keep in mind. Right? Bitcoin is peer-to-peer electronic cash that exists independently of any trusted third party, centralized issuer or controlling authority. And that's what makes it distinct from everything that came before it, effectively. And this was an incredibly revolutionary idea to people, in part because it was previously believed to be more or less impossible. And maybe it is impossible, right? Bitcoin is also experimental, and it may be gone at some point in the future. We don't know. And its current 8-year or so lifespan suggests that isn't the case. But it's still it's a very new area. And so what does Bitcoin give us? It gives us a new kind of fiat money. And I use fiat money in the sense that economists use it, right? It's a money whose value comes basically purely from network effect. It doesn't have an intrinsic value. It's valuable because people are willing to accept it. And in the past, it's been very difficult to create fiat monies because of the problem of, well, if anyone can create them, then they're kind of worthless. And so you've normally only seen fiat monies created where an authority had the power to force people to use it, where you could have like a legal tender status for a government-issued currency. And Bitcoin offers something different. It's a consensual, voluntary kind of fiat money that people can choose to use or not use, and choose to create their own alternative to as well. And so this gets used as a store of value. It's used as a hedge against inflation, against monetary policy. It gets used for payments, especially international payments, and all the other things that money gets used for, including drugs and fraud and all sorts of seedy stuff as well, right? But that's in part just showing that it is, in fact, a money that people are using. So one of the other things, though, to keep in mind is that Bitcoin's also a novel cryptographic protocol, no less than TLS or any of the other protocols that we use today. And as a cryptographic protocol, it's very fragile in a technical sense, right? If anything is wrong with your crypto system, it may be completely insecure. And it's also much easier to come up with a new crypto system and sort of convince yourself, oh yeah, this is secure, when it really isn't, right? And so the history of cryptography is full of broken algorithms that seemed really strong until someone squinted a little bit and then they weren't. So it takes time to figure out that this is solid stuff, and people need to learn to analyze it. So Bitcoin's been going for a long time now, and that's some existence-proof evidence that it's pretty strong. But many of the new ideas that we're coming up with in the Bitcoin space and beyond it are a lot newer, and it'll take time to be confident in those as well. So one of the challenges with Bitcoin is that it inspires some hard questions, right? If you think about Bitcoin, you might say, well, what is money? Like, what does that mean to us? What role does it have in society? It begs us to ask, who do we trust? Why do we trust them? What do we gain from that trust? What are the risks of that trust? What are the costs of that trust? And once we've gone through and realized, man, all this trust stuff is actually kind of costly, we might ask the question, can we build systems which are more decentralized, more autonomous, more cooperative, and that remove middlemen? If the public is given a choice, what kind of money would they prefer to use? The central banks of the world offer particular sets of monetary policies engineered to benefit society and the economy, but people are sort of forced to use them. If you give people a choice, what happens? And then this ability to create a new kind of fiat money builds an opportunity for basically creating investment assets. So Bob shows up, and Bob says, I've got Bobcoin, and it's Bob better than Bitcoin. And if you buy it now, you will make $1 billion. Bob might be right, or he might be wrong, but whatever, Bob's annoying to listen to. So this is all this awkward stuff that comes out of talking about, particularly the currency applications of Bitcoin. And so many people have looked at this and said, this Bitcoin thing, I don't know, it sounds like gold bugs, it's a little weird. But blockchain, can't we just blockchain instead and forget about this Bitcoin stuff, because the Bitcoin stuff's kind of weird? Well, so this begs a question. What the heck is a blockchain, right? Now, you can answer it in a very pedantic technical sense. There's a part of the Bitcoin system that's a blockchain. But that is what I found, not what people are usually talking about when they say they want to use a blockchain for an application. So let me break this down a little bit. I heard this great quote a couple weeks ago from Fed Chair Janet Yellen talking about a variety of things, and she was basically asked impromptu in an interview with no preparation, what is blockchain? And I think she gave actually a really good answer. So what she said was that blockchain is an important technology. It's a core technology embodied in Bitcoin. She said that her understanding is that it is a technology that enables transactions and ownership of things to be taken care of automatically without a need for a trusted central party to record transactions. It's a very important new technology that could have implications for the way in which transactions are handled throughout the financial system. So I think this is actually a pretty good starting definition, except that she used the uncountable noun blockchain, which makes many people cringe. But it's also not very specific, right? It says it's a core technology embodied in Bitcoin. And as I was just saying, I don't think the actual blockchain part of Bitcoin is what people are really talking about when they say that they're using blockchain technologies. So which core technology in Bitcoin is it? So let's talk about what some of the core technologies in Bitcoins are. And I've classified them in this set. You could classify them in other ways. But I think this is a good breakdown. So Bitcoin is constructed from a number of components that were well known and used before. The first one's digital signatures. The second one is authenticated data structures. The third one is smart contracts. The fourth one is proof of work consensus, which is new and novel to Bitcoin. And then the last one is the mechanical verification and real-time audit. So I'm going to explain a little bit about how I think of these things. So the first, and in many ways the most useful technology in blockchain, is digital signatures, which are, in one sense, not new at all. We use them every day. So digital signature should probably really be called something else, though, because the signature thing is a little misleading. A digital signature is more of a seal. Right? And what it does is that it allows you to show that a party, knowing a secret key, authorized a document or created a document. That's what a digital signature does. And I say seal instead of a signature because it actually locks together. So it's like a wax stamp on the document that if you change the document, you invalidate the seal, right? So these have long been used for computer authentication and really not in a lot of other places. Part of the reason that I think they're underutilized in commercial applications is key management. And basically, this is an unsolved problem. People try to deploy cryptography and digital signatures in organizations, and what they deploy ends up often not being used or useful because of the problems of key management. And Bitcoin doesn't solve key management. Now, what it has done, though, is it's given people a lot of incentive to go and build better key management tools. And so there's improvements. But it's also shown people that even if you haven't solved key management, digital signatures are still a fantastic technology, and even a poor use of them is better than not using them. So the next component core technology of Bitcoin I wanted to talk about is authenticated data structures. So this is the technical blockchain part of Bitcoin. Interesting aside is the Bitcoin white paper uses the word block many times. It uses chain many times, but it never uses the phrase blockchain. But when people are talking about a blockchain, they're usually talking about the actual data structure that's used. So what is an authenticated data structure? Well, first you start with the concept of a cryptographic hash, right? Which allows you to take an arbitrary amount of data, pass it through a function, and get back a short value, which has a number of really useful properties. But the most useful that I'd like to talk about here is that it's infeasible to compute two different messages that have the same cryptographic hash, at least if the hash function is good at all. So I can give you something like I can basically take something like an encyclopedia. I can compute the cryptographic hash of it. I can give you the cryptographic hash. And then later, if someone else shows you this whole encyclopedia, you'll be able to verify that the encyclopedia that you got matches the hash I gave you before. So I gave you this authentication value, and you were able to check against it. But if you just do that, if you take the whole encyclopedia and feed it to a cryptographic hash, the result requires you to hash the whole thing yourself in order to validate it, and this is pretty slow and inefficient. And so what if you want to check only a single page? Like, I've only given you one page of the encyclopedia, and you'd like to check to see if it matches this authentication string I gave you before. Well, you can't do that if you just use a hash directly. Or what if you want to make updates to this and then update the hashes? You'd have to update it and then rehash the whole thing. So the idea behind a generic authenticated data structure is that you can take any kind of information and you can divide it into a hierarchy. So you can say, take an encyclopedia, and you can say, well, there's a book, and it has sections, and each section has chapters, and each chapter has pages, and each page has lines. And you can hash along that structure. So you can define the hash of a page is the hash of the hashes of each of its lines. And you can say the hash of a chapter is the hash of all of the pages in it, and the hash of a section, and so on, right? So you've built this hierarchy out of it. And when you've done this, a kind of magical property emerges, which it becomes possible for me to show you a single page of this encyclopedia and then give you a little extra information, basically the additional hashes from each level of this hierarchy. And now you can check that the single page came from the encyclopedia, but I haven't given you the whole encyclopedia. So that's what authenticated data structures allow you to do. And you can apply this to any kind of data structure, a balanced tree, a red-black tree, a flat piece of information. Particularly if the data structure is recursively defined, it can be quite efficient to do lookups and accesses using an authenticated data structure. So that's great, and that's what the blockchain component of Bitcoin technically is. But it's actually not that an exciting piece of technology in and of itself. It's an elaboration on authentication, right? But by itself, it's not that terribly exciting. And in the case of the Bitcoin system, the blockchain is just applying this authenticated data structure technique to a linked list, the blocks, and then within each block to a binary tree. And it's just applying that along the system. So the next core technology in Bitcoin is smart contracts. And Bitcoin has had smart contracts from the very beginning. And the rationale for it having this system is that if Bitcoin's value comes from avoiding third-party trust, that value is diminished if every time you go and use Bitcoin, you're having to trust a third party to execute your deal fairly, right? And so the notion to improve this is that instead of just trusting a third party, what if you're able to take the rules for your transaction, encode them into a little program, and attach that to your transaction and say, this transaction can only be paid if this program is satisfied. So this is how Bitcoin works, and in fact, every normal payment in the Bitcoin system uses this script that says, provide a digital signature with this particular key, kind of a boring application of it. But there are many interesting ways you can use this to provide automated escrow and other interesting kinds of trades. And as people have talked about at some other sessions during the conference, this functionality gets used to build additional scalability tools on top of Bitcoin. But the development of fancier services using smart contracts is really a new area. Every smart contract is itself a cryptographic protocol working in a distributed context. So it's very difficult to be sure your smart contract is doing what you think that it's doing. Proof of work consensus is perhaps the biggest of the innovations in Bitcoin, but it's also the one that doesn't get picked up in the private applications. In particular, because proof of work consensus doesn't clearly work in a private environment. So the idea is that classical consensus requires a fixed set of participants, which isn't particularly good for being distributed, and it requires quadratic communication, which isn't efficient when you want to have lots of participants. And Bitcoin discards all of that and uses a fair lottery constructed out of hash functions to decide who can update the ledger, who gets new issued coins, and to also make the chain immutable. And you can look at this proof of work consensus as a digital signature itself. This proof of work that's happening in Bitcoin is basically a signature of energy. It's saying that a certain amount of energy was put in making the Bitcoin system and the blockchain immutable. So the last of these top-level components in Bitcoin is this mechanical real-time audit. Every node in the Bitcoin network independently validates the rules of the system. And the effect of this is that whole classes of vulnerabilities, of cheating, of fraud just become impossible because the nodes will simply ignore it. Now, this is pretty inefficient to have all of these participants in the network redoing exactly the same computation over and over again. But computers have become really fast, and so it's quite practical to do this on a pretty large scale. But making it useful requires actually defining a complete set of rules in a mechanical enough way that you don't need human intervention all the time, because then otherwise you're undermining this real-time audit. So I guess the point that I would bring here is that each one of these technologies is a little bit interesting on its own, but maybe not all that powerful by itself. But in Bitcoin, each one of the technologies works with the others to amplify each other. So blockchains are often called immutable, but the immutability doesn't come from a blockchain. One of the advantages of an authenticated data structure is that they're easy to update. In Bitcoin, the immutability comes from the combination of the blockchain with proof of work and with the real-time audit and with economic and social constructs around using the system. So these tools are important and they're powerful and useful, but they're not magic. So where are they best applied? I think the most important thing to keep in mind, going back to Janet's comment earlier, is that trust is involved, right? The systems get rid of trust. So basically, the blockchain and Bitcoin use cases are best when there's a fundamental dispute resolution problem that we're trying to solve. So the world has many different ways to resolve disputes, but many of them are costly and unfair, right? If you have to trust someone to resolve your disputes, they have market power, which prevents new entrants, which allows them to extract monopoly rents. It's not a great environment. we often ignore these things because there's no way to avoid trust. So we ignore the costs and just pretend that they're unavoidable. But sometimes we can avoid them. In particular, these trust issues are especially important when we think about machine-to-machine transactions. And the issue here is that machines can't evaluate trust on their own. So if you want to have an Internet of Things device that interacts and exchanges value with another Internet of Things device, they basically have to be hard-coded to know who they should trust and who they shouldn't, which makes them less useful. So what Bitcoin presents is a new kind of dispute resolution, which only clearly works when the rules are machine decidable, when the facts are cryptographically authenticatable, and under certain economic assumptions. But where they work, you get an asset that's usable worldwide, that's relatively inexpensive to use. So these are kind of global, long-scale societal benefits. So where do these things apply within, say, a single company? The notion that you can trust everyone inside your organization is a failed security practice. We should know this doesn't work. The insiders attack and embezzle, firewalls get punctured, and a better assumption would be that there are no private networks, there are no closed organizations in the world, and any system that doesn't work securely on the internet probably can't be secure inside your corporate network. So we can also think about applying the same trust mitigations that come out of this blockchain tool bag at a small scale within an organization and gain some value from them. One of the very important powers of this technology is enabling decentralization. Many people have observed in the past, many years ago, we can decentralize service X. We don't need Facebook, we can have decentralized Facebook. We don't need centralized file storing, we can have decentralized file storing. But many of those technologies get stuck in this cycle of pointlessness where there's one component in the technology that has to be centralized. And if that one has to be centralized, well, you might as well centralize the whole thing because you're already depending on that one point. In many cases, because of the regulatory environment around money, money is the thing that has to be centralized. And so in those applications, if money was the thing that was blocking you from having a decentralized solution, Bitcoin basically solves that. It gives you an internet money that can be used by anyone, right? And so that enables just a whole lot of applications that are not blockchain or not Bitcoin, but are just enabled and can be available to everyone as a result of having this extra tool in our tool bag. So to sum up what I've been talking about, this is all new technology, and being skepticism is justified. Something can be awesome, but still be uncertain. When we talk about blockchain, right, it isn't just a single piece of technology. It's not just this authenticated data structure component. It's a collection of technologies, many of them in Bitcoin, maybe ones that aren't in Bitcoin, that work together to do useful things, in particular when they can mitigate trust. And you have to be very careful to look that you're not basically trust laundering, that you haven't applied a blockchain and then there's really a really highly trusted component and you've just sort of hidden it away in the system, because then the value isn't delivered. And a key point here is that any of your blockchain technology must be open source, because otherwise you're just blindly trusting the software. Any useful solution requires this mix of technology. These things are cryptographic protocols. They have to be understood in their totality. And I think that really the most amazing applications of this stuff, except reinventing money, have probably been yet to be discovered. So, thanks. Yeah, anyone have any questions or stuff to chat about with me? We've got a couple minutes.
Quick question for you. If you had a chance to respond to Janet Yellen's comments, what would you tell her?
Stop using the uncountable noun blockchain. No, I think her comments are really spot on, though a little vague. And I think that it's fine that they're vague, because we don't really know what blockchain applications are going to do for us in the long term. I was very pleased that she specifically mentioned Bitcoin and didn't cut it out of the discussion. I actually noticed many of the press repeating her comments did actually remove all mention of Bitcoin. So.
Really interesting presentation, Greg. Just a couple of things I'd like to hear extra thoughts on. Number one, you said if you're just moving centralization from one aspect of the structure to another, why bother? I'm kind of the view that potentially there is a superior system, even if you're moving that source of centralization.
I would agree, but you need to ask the question.
Yep. OK, cool. And the second part is, what are your thoughts on transitional arrangements? So obviously, technology such as like the AI judge or zero-knowledge proofs aren't quite there yet.
Yep.
So perhaps it's better to build a system that's transitional towards that perfect end goal, even if it's not the ideal solution at this point in time.
Yeah, I would agree with that. The point is we always need to be completely frank about what we're doing and not just talk about the end goal when we haven't gotten there yet, because there's a risk that we will erode people's confidence in the technology when it fails to deliver on the dreams. And this stuff is so awesome, you don't need to overplay it. And so long as we're clear about what we're doing, transitional technology is great too.
Greg, you didn't mention the math of incentives that sustain all that.
Yeah, that's a real interesting challenge. What Bitcoin does compared to many other cryptographic protocols is that it does not achieve an exponential gap between an attacker and a defender, which is unusual for a cryptographic protocol. And as far as we know, it's not possible to achieve one for this kind of system, which means that the defenders have an advantage, but it's not huge. And because of that, systems like Bitcoin depend a lot on social constructs, economics, and the incentives around them. And that's one of the reasons that it's always important to analyze what we're doing very carefully, because if the incentives aren't there, it may not be secure, even if Bitcoin is completely secure, because it has the incentives. All right. Thank you.